So now you're going to go into trying to understand why these substances are different. Why do they have different physical properties and chemical properties? It all comes down to, as I've said before, the type of atom that it has, and how it's organized in that substance. That essentially is the big thing. But that type and organization then affects how it reacts in different situations. So in this case, we're going to look at what happens when we heat or cool a substance. When you heat or cool a substance, you're changing how much energy it has. That's the key thing here, the amount of energy it has. As you go from a solid to a liquid to a gas, and even further up to a state we call plasma, you are increasing the amount of energy that substance has. And if you give it enough energy, it will actually have the particles push apart and melt, so it go from a solid to a liquid, and then push apart even further and then go from a liquid to a gas. But how much energy it needs to do that transformation depends on the substance. So every substance has a unique melting point and boiling point. That's how much energy it needs to literally have its particles push each other apart and go to a liquid or to a gas from its solid state. That's unique to the substance, and we can measure that and use it to help identify it. The other thing that we often don't talk about is the fact that in between these states, from solid to liquid and liquid to gas, that substance can often be expanding or contracting, but we don't realize it. So as you give a solid a little bit more energy, and it's not enough energy to actually turn into a liquid yet, but the particles are starting to move around and vibrate, well, they start to push each other apart. And as they do that, it expands. It hasn't melted yet, but you can see it expanding, especially if it's like a metal. They do this very well. And it will actually change its size, its volume, because it will change shape, it will expand and get a little bit bigger. And this happens an awful lot when metal roofs and that get hot in the day. You can hear them creaking and groaning as the metal expands, and then in the afternoon, as it contracts, you can hear them creaking again as it contracts back because it's cooling down. Now the same thing happens from liquid to gas. As the liquid heats up, they start pushing and hitting each other a lot with more energy, and so they push each other apart, and again, liquids expand before they evaporate. And the opposite happens when they cool down. They condense, okay, or contract as they cool down. Okay, so as they cool down, they contract. As they heat up, they expand and change their size. And that is another thing we can measure and add to the property profile. And I've got a little picture here that helps you to understand that a little bit better. Here we have a solid. This would be, say, a metal. And as we add energy to it, it will actually increase because these particles here will have a lot more energy. And as they gain energy, they'll actually start to push each other apart because they start to vibrate. If it's a solid, they'll always be vibrating. And if it goes into a liquid, they'll not only vibrate, but then they'll start moving around as well. But for now, it's vibrating with lots and lots of energy, and because of that, it pushes all the particles, essentially, and it expands in size. And then as you cool it down, over here, you can see it goes back to what it used to be in its shape. So that's how expansion and contraction work. The particles have more energy to push each other apart, but not enough to push each other apart to melting point. They're simply expanding a little, and then they contract back to what they were before.